हेलो दोस्तों, कैसे हो? मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं। टॉपिक डेजिग्नेशन ऑफ स्टील। No, you must have seen many times I have written this number here, 20 C8 or 45 C4, something like this. So what is this? It is a number which is telling that this is what? It is telling that this is mild steel. What is this? This is mild steel. If I say 1841, what is this? This is high speed steel. If you go to purchase material in the market, they will ask you, if you ask for mild steel, either the person will give any material which is available, or if he has little bit of knowledge, the person will ask you which mild steel, what is the configuration, what is the grade, what is the specification. So if you go to industry, there also you can see that on the material which is piled up at one location, there you will find that something like this is written. This is not found. You will not find anything like this is written. Okay, you will find numbers are written like this. So whenever you are using material in industry, you have to use it by grade, because if this 20 C8, 20 C8, if it changes to 25 C8, the property of the material changes. Property of the material changes, and depending on the, because here you are increasing the percentage of carbon. 20 C8 is percentage of carbon 20. This is also percentage of carbon. So from 20 to 25, we are increasing the percentage of carbon. It's not 25%. It is a number. I will tell you in a few slides. But you are increasing the percentage of carbon here. Now, since the percentage of carbon is increasing, it is going to change the property of the material. So in industry, you have to use this numbers or designation only. That is this topic, designation of steel. So designation of steel is done on the basis of one, mechanical property, and number two, on the basis of chemical composition. So this designation which I which I have shown you here is on the basis of chemical composition. And how do we do designation of steel on the basis of mechanical property, that we'll see now. Now, when we designate a steel on the basis of chemical composition, it will be either carbon steel or plain carbon steel. It will be free cutting steel, low and medium alloy steel. It will be high alloy steel, and it will be high speed tool steel. So now we are going to see the designation for this. Number one, carbon steel or plain carbon steel. This is also called as what? This is also called as mild steel. Second is free cutting steel, low and medium alloy steel, high alloy steel, or this is tool steel, which is used for making the tool material. This is tool material. How will we designate this? Okay, this is what we are going to see now. So first we'll see how do we designate the steel based on mechanical property. Also, when you will refer the question paper, or you will refer the textbook, we will come to know that instead of writing mild steel or instead of writing cast iron, they have written this number. Okay, or they will write FG 350. What is this? This is gray cast iron. Okay, so you have to remember this. You have to remember this. So we'll go through this one by one. First is designation of steel on the basis of mechanical property. The mechanical property that is selected here is yield strength. Okay. Okay. Coming back to this, on the basis of mechanical property, how do we designate a steel? We have selected this mechanical property. What is that? Tensile strength. We have selected this mechanical property, tensile strength, to designate a steel. You know where we get this tensile stress in the stress strength curve. Upper yield point, somewhere here upper yield point, lower yield point, and here we get the SYT, yield strength, and here you get what? SUT, ultimate strength. So this is based on yield strength, minimum tensile strength or minimum yield strength. And how we designate it? We say Fe290. So instead of giving the material to you that it is a mild steel, it is a mild steel, what will be given to you? The material for shaft is, for example, Fe290. So what you understand from this Fe290? Fe means steel. Fe means steel. To be specific, mild steel. And what is this 290? It is the tensile strength or yield strength. In what unit? Newton per mm square. Okay, Newton per mm square. It is tensile strength. Or if the letter E is here, then E is Young's modulus. So it is what? Yield strength. It is yield strength. Okay, so it can be minimum tensile strength or ultimate tensile strength. This minimum tensile strength can be this ultimate tensile strength. Where do you get this? Here. Ultimate tensile strength here, where we get the fracture of the material. Okay, so this is ultimate tensile strength. So minimum tensile strength is this, or it can be minimum yield strength. Yield strength is this, where we have a letter E. So based on this, you can understand, okay, this 220, this is yield strength. Okay, I just divided by factor of safety. So I can take a factor of safety of say 2 and it will be 1 by 10 permissible stress. Oh, okay, this is ultimate strength. So yield strength may be much below than this. So I will take 4 as factor of safety and I will design this. Then next is designation of steel. We have seen there are two ways in which we can designate a steel. One is on the basis of mechanical property and second is on the basis of chemical composition. So we'll see this 5 now. We have already seen this now. Either it can be Fe290 or Fee220. Now the second is based on chemical composition. So how a steel is designated, you can see here. Now this plain carbon steel, it can be classified as dead mild steel, low carbon or mild steel, medium carbon steel or high carbon steel. This depends upon the percentage of carbon involved in it. Okay, if it is up to 0.15%, if it's up to 0.15%, then it is called as dead mild steel. If the percentage of carbon is from 0.15 to 0.45, it is called as low carbon steel or generally mild steel. So whenever we say mild steel, it means that the percentage of carbon is from 0.15 to 0.45. I am repeating, you remember this. Whenever I am saying mild steel, it means that it is a plain carbon steel which contains carbon from 0.15% to 0.45% on an average. Then if I am saying about the medium carbon steel, then it contains carbon from 0.45% to 0.8%. And if the carbon is from carbon content is from 0.8% to 1.5%, then we call it as high carbon steel. And what if the carbon content is more than 1.5? It is called as, okay, so if the percentage of carbon is more, then we call it as cast iron, correct? Then we call it as cast iron. So according to the Indian standard, the designation of carbon steel consists of the following. Quickly we will see what is it. It is 40C8. So when I say 40C8, you can see the cursor 40C8. It is a carbon steel. Now we'll understand what this 40C8 means. 40C8 is carbon steel. It means a plain carbon steel containing 0.35 to 0.45% of carbon. कितना कार्बन रहता है 0.35 to 0.45. ये कैसे पता चला अभी? See here, a figure indicating 100 times the average percentage of carbon. So this is 40. 40 is indicating what? Percentage of carbon. कितना times बताता है? 100 times. So 0.35 to 0.45 का average कितना हो जाएगा? It will be 0.40. And 0.40 into 100 is how much? 40. So that's why it is 40 here. So when I say 40 C8 में से when I say 40, it is percentage of carbon and which is 100 times. Then a letter C, this is a letter C, and then third is a figure indicating 10 times the average content of manganese. So 8 is what? 8 is indicating the percentage of manganese, and how much it is? It is 10 times. So 10 times of 0.8. You can see here 0.7 to 0.9. What is the average? 0.8. So 10 times of 0.8 is how much? 8. So that's why it is 8. Similarly, you can see second example 25C4. So when I say 25C4, it is a plain carbon steel and it contains 0.25% of carbon on an average and it contains 0.4% of manganese on an average. Second designation here is of free cutting steel. So let us understand what do you mean by free cutting steel. Actually, I forgot to put animation in this video, today's video. Anyway, so the entire thing is displayed at once. Free cutting steel contains sulfur and phosphorus as the main alloying element. So in a free cutting steel is basically a plain carbon steel. And in the plain carbon steel, what is added? Sulfur is added, phosphorus is added, or sometimes lead is added. So by adding sulfur, phosphorus, and lead, we improve the machinability of the steel. And as the machinability of the steel is improved, it is called as free cutting steel. Okay, and the thing to be noted here is that the machinability of the steel is improved without the loss of toughness. It still remains tough enough. Okay, so that is called as free cutting steel. So what is new in the free cutting steel as compared to plain carbon steel? Either sulfur or phosphorus or lead. Now, how will we understand whether it is a free cutting steel or a plain carbon steel? So you can see here symbol S or P or Pb. S for sulfur, P for phosphorus, and Pb for uh, lead. This symbol is followed. So if I say 25C4 and then there is S20, it means that I am talking about what? I am talking about free cutting steel. When I say that there is a letter P or Pb or S, it means that I am talking about free cutting steel. Let us see the example here. Actually, 25, you can see directly see the example 25C12S14. So if you ignore this S14 part, then what we will read? We'll read it like this: 25C12, and 25C12 can be easily understood as a plain carbon steel. Correct? So 25C12 is plain carbon steel, and it is followed by S14. It means it is a free cutting steel. Is it clear? So this S14, or in the second example you can see S12. This distinguishes the plain carbon steel from the free cutting steel. And why is the alloying element added? Alloying element is added to improve the machinability, and that's why the name is free cutting steel. It cuts freely as compared to the plain carbon steel. So you can see here 25. 25 is the percentage of carbon 100 times. So 0.25 into 100 becomes 25. Then C12, it is 10 times. So 1.2 is the actual content into 10. So it becomes this one 12. And then sulfur is how much? It is 100 times. So 0.14% is the sulfur on an average. You also understand the meaning of this on an average. On an average, matlab 0.14% is an on an average. Matlab it can range from 0.12 to 0.16. Correct? 0.12 to 0.16. It can range from 0.11 to 0.17, something like this. So 0.11 to 0.17, average of 0.11 and 0.17 is 0.14. So it can be in the range of that. So that's why it's written on an average. Now you can see high alloy steel are the steel which contains more than 9% of the alloying element. Now what is alloy steel? Alloy steel is the steel which contains alloying element. Now alloying element means like phosphorus, lead, sulfur are also alloying element, and they are not added. You can see the content of phosphorus, sulfur or lead which we are talking about here. Okay, so it is from the example you can see it is less. See 0.14% of sulfur or 0.12% of sulfur here. So the content of this alloying element is very less. Major content here is of carbon. Okay, but this alloying element is very less in content. High alloy steel is also a steel which contains some alloying element. But what are the alloying elements which make it high alloy steel? The alloying elements are generally nickel, chromium, molybdenum, like this. So these are the elements which are added to make it a high alloy steel. Okay, and how the high alloy steel is identified? It is identified by the alloying element, and the alloying elements are generally more than 9%. Okay, so that I will again explain you in this designation. What is this 9? So what is the sequence? It will always come in the sequence like this. First there will be letter X. Okay, then after letter X there will be a number which is indicating 100 times the average percentage of carbon. Okay, then there will be a chemical symbol for alloying element. So you can see that there is no letter C here. Generally, we have letter C after the percentage of carbon. So that letter C is not here. So first is letter X, then is the a figure which indicates 100 times the average percentage of carbon, similar to the plain carbon steel of recutting steel, and the letter C is missing, and then directly we have chemical symbol for alloying element, and each followed by the average percentage of the content of the alloying element. How is it designated? You can see here 10, Cr, 18, nickel 9. Okay, 10, Cr, 18, nickel 9. So you can see there is a letter X here. So this letter X helps us to understand that it is a medium, it is a high alloy steel. But always this letter X may not be present. You can read it by skipping letter X. What is it? 10, Cr 18, Ni 9. So when I say like this, then there is no letter X. Then also I am able to understand. Uh, just a second. Okay. Sorry for the interruption. There was someone who has come. So I was talking about this letter X. Even if the letter X is not there, I can still guess that this is a high alloy steel. Why? Because this 9 indicates that it is a alloying element. It is the content of alloying element, and which is the alloying element? Nickel. This 18 indicates that it is a content of alloying element, and which is the alloying element? It is chromium. So there is no manganese content in this. Okay. Now this does not mean that this high alloy steel contains only carbon, chromium, and nickel. It contains other elements also. But this chromium, nickel, and carbon are the major alloying elements. Oh, sorry, chromium and nickel are the major alloying elements. So how will you read it now? X, that is X indicates the high alloy steel. 10 indicates the percentage of carbon, how many times? 100 times. Cr is the alloying element, that is chromium. Its percentage is 18, so chromium is added, 18% chromium is added. Then next is nickel, and 9% of nickel is added. So even if this X is not there, I can understand that okay, there is a alloying element like chromium and nickel. So since chromium and nickel is the alloying element and its content is 9 or more than 9, okay, so I can understand that okay, it is a high alloy steel. So even if this letter X is not there, I can understand this. Similarly, you can see for the second example, X30. So forget about X. Say 30, 30 is the percentage of carbon. How many times? It's 100 times. Then chromium is the only alloying element which is added. There may be other alloying elements, but those alloying elements may be in less quantity, and so it's not indicated in the designation. Similarly, we can see for the third example, X45. X indicates it is the high alloy steel. 45 indicates that it is a percentage of carbon which is 100 times. So actual percentage of carbon is 0.45. Chromium is 9% and silicon is 4%. 4%. Actually, this is written nickel. It should be silicon Si on an average. And similarly, this is left for you to complete. So coming to this slide, these are the four things which are there in the symbol. Letter X, then about the carbon percentage, then the chemical symbol for the alloying element and its content, and another chemical symbol if it is added, or else if it is not added then it will be only one, as you can see in this case. So this is the designation of high alloy steel. Is it clear to all of you? Okay, hopefully clear. Yeah.
Yes, sir.
Okay. Now I will come to low and medium alloy steel. Now since we know that high alloy steel is generally containing 9 or more than 9% of alloying element. So now this number 9 is not a fixed number. Okay, this is not a fixed number. Sometimes it can be slightly less than 9, or if it is greater than 9 then surely we can say it is high alloy steel. So this is not a fixed number, and there is no fixed line which will distinguish between high alloy steel and medium or low alloy steel. Okay, it is just a number to indicate, okay, it is high alloy steel. So it is not 100% ensuring that it is high alloy steel only. Sometimes it can be 8 also. Okay, so there is no fixed borderline which will say that this is high alloy steel or this is low alloy steel. Low and medium alloy steel, it comes together, low and medium alloy steel. Again, similar to what we have studied up till now, a figure indicating 100 times the average percentage of carbon. So that is, you can see here 40, 40, figure indicating the percentage of carbon. Then chemical symbol for alloying element. So you can see there is no C here, no letter C. So letter C is used only in carbon steel. Letter C is used only in plain carbon steel or free cutting steel. That is also carbon steel only. So in low alloy steel, you will not see letter C. In alloy steel, you will not see letter C. Okay. So there is no letter C. So directly the percentage of carbon and the alloying elements. You can see here chromium is 4, molybdenum is 2. So you can guess from this that this cannot be a high alloy steel. It has to be low or medium alloy steel. So this low and medium alloy steel is put in the same category, and there is no line of distinction between the low and medium alloy steel. Generally, if it is low alloy steel, means it is as good as plain carbon steel only. Some alloying elements are added just for the purpose of increasing the particular property. Now you can see here this Cr4 means a low and medium alloy steel containing 0.4% of carbon. Till here it is okay. 1% of chromium. Now you must be thinking that Cr4, so it should be 4% of chromium, or if it is 100 times then it is 0.04, or if it is 10 times then it should be 4%. But it is not that way. The designation is put in such a way that it is 1% chromium. So how this 1% is written as 4? Understand this. So we have a multiplying factor. You have a multiplying factor for different elements. Now we are talking about which element here? Chromium. So 1% of chromium, and this 1 is multiplied by 4. Why 4? Because for these elements the multiplying factor is kept as 4. So when I say 1% of chromium, so in designation it will be 1 into 4, that is 4. So chromium is 4. Okay, see here in this case, in the third example, we'll talk about chromium first. Cr2. So it is 0.5% of chromium, actually 0.5 multiplied by 4. So 0.5 multiplied by 4 comes out as 2. So while writing in designation, I will write it as 2. So Cr2. Is this clear? Any doubt to anyone? I will repeat it again. While writing the designation of low and medium alloy steel, there is a slight change made, and the change made is like this. While writing the designation, we are not writing actual content of that alloying element, but we are multiplying that content by some multiplication factor. For example, if it is a chromium, cobalt, nickel, manganese, tungsten, silicon, and then for those the multiplying factor is 4. Similarly, for this aluminum, beryllium, and also the multiplying factor is 10. And similarly for PSN, and the multiplying factor is 100. So if I am talking about chromium, the multiplying factor is 4. So how much percent of chromium is there in the element? It is 4%. Sorry, it is 1%. and 1 is multiplied by 4. So in designation it will be Cr4. I am explaining you one more example of chromium here. See, chromium content, average content of chromium is how much? 0.5%. But then we will not write this 0.5%, we will multiply it by some multiplication factor. So 0.5 multiplied by 4, which is the multiplying factor for chromium. So 0.5 multiplied by 4 is 2. So here we are writing 2. Is this concept clear to all of you? Okay, now there may be a question in your mind why we are multiplying it by some multiplication factor. So we are multiplying it by some multiplication factor because every time this is low and medium alloy steel, so the content will be very less. So when the content will be very less, here we will have to write 0.5. So instead of writing 2, we will be writing 0.5. Okay, for Mn. MnC, what is the multiplying factor? Again, Mn multiplying factor is 4. So 0.5 for of manganese. So here what we'll write 11 Mn 0.5. Just to avoid this, they have specified some multiplying factor, and that's why we are using the multiplying factor to write the designation. Any doubt? Okay, so no doubt to anyone. I think the things are clear till here. Yes, Sahil?
No doubt, sir.
Okay, Sahil? Sahil? Sahil Dastagir, are you there? Okay, Sahil is not present, so is gone somewhere. Harsh, Harsh Tillu.
Yes, sir.
Okay, is the concept clear to you?
Yes, sir.
Okay, good. So now we have understood that the designation of low and medium alloy steel is given like this. So I have till now I explained you 4 designation. Out of the 4 designation, the first designation that I have explained, which it does not need what? Okay, Sahil is there. Said yes. In the first 2 designation, what we need a letter C, and that letter C will make us understand that it is a either plain carbon steel or a free cutting steel. Again, to understand how to distinguish between plain carbon and free cutting steel, we have the added element written as P or something like that, and the content is how much? It is 100 and 10. You can remember it like this. First is 100 and then is 10 in plain carbon steel. And this here, it is 100, 10 and again 100. So this way you can remember. You find out whatever ways you can remember. So for first plain carbon steel, it is 100 times and then 10 times. For free cutting steel, it is 100 times, 10 times and then again 100 times. Okay. Now coming to the third and fourth, that is alloy steel. If it is a low and medium alloy steel or if it is a high alloy steel, there is no letter C. No letter C means it the पहला दो cases चला गया. Then depending on the content, alloying element content, we can identify whether it is low and medium alloy steel or it is high alloy steel. Generally, if it is 9 or more than 9, it can be high alloy steel. Okay. And if it is less than that, it has to be low and medium alloy steel, and low and medium alloy steel is written by multiplying the average content by some multiplying factor. So you will have to remember the multiplying factor for these elements. For example, this uh, zirconium or molybdenum is coming in the designation. Then you will have to remember that for these elements the multiplication factor is 10. So either you can remember this PSN or and this, and then remaining will be 10, or anyway the way you want to remember it, you have to remember. I think this is available in the design data book also, so no need to remember. But yes, you should know what the designation is. Type of steel here is high speed tool steel. So if it is tool steel means the steel which is used for manufacturing of tool material, then it will have these elements like what? Tungsten, it will have chromium, it will have vanadium. Major alloying element: tungsten, chromium, vanadium. In fact, 18:4:1 Okay, this is high speed steel, HSS, which you must have heard about in machine shop or in um, any subject, machining related subject. 1841 high speed steel. So this is tungsten, chromium, vanadium. This is fixed constitution, so it is sometimes also called as 1841 HSS. So here what we have, again similar to what we have seen earlier, we can see now forget about this XT. This is just a prefix. Even if it is not there, we can identify. See how 75 is there, percentage of carbon, high percentage of carbon. Okay. Then what are the alloying elements? Understand the alloying element: tungsten, chromium, vanadium. You can see cobalt, chromium, vanadium. Cobalt is also used as tool material. Tungsten. So whenever you get this tool material, material like tungsten, chromium, vanadium, cobalt, then we can identify that yes, it should be high speed tool steel. It should be high speed tool steel only. If it is, if the alloying elements are tungsten, chromium, or vanadium. Just a minute, students. Okay, so from this we can identify whether the material or the designation that is given to us is of alloy steel, lower medium or high alloy steel, or whether it is plain carbon steel, or whether it is high alloy steel. That is tool steel. Sorry, not high alloy steel, tool steel. Okay, then this cast iron designation is not in the syllabus, but still I will explain the one or two designation of cast iron so that you should understand what exactly it is. Because when you are solving or numerical, when we are solving the numerical, that time this comes in some or other question. So cast iron is gray cast iron, nodular cast iron, spheroidal cast iron. Uh, there are various grades of cast iron. Cast iron that I am explaining here is gray cast iron. So this is the Indian standard specification. According to this specification, IS 210 1993, the gray cast iron is designated as FG. G is gray cast iron, F is iron, that is cast iron, and G is gray. G stands for gray, and it is indicated by the minimum tensile strength, that is ultimate tensile strength, that is 150. So FG 150 means it is a gray cast iron which is having the ultimate tensile strength of 150 Newton per mm square or 150 megapascal. Okay, Newton per mm square is same as that of megapascal. FG 150. Okay, so again we are talking here about टेंसाइल स्ट्रेंथ. मिनिमम टेंसाइल स्ट्रेंथ का मतलब ही वही होता है अल्टीमेट टेंसाइल स्ट्रेंथ. Then malleable cast iron. So in malleable cast iron again there are two types: white heart malleable cast iron and black heart malleable cast iron. And there is also pearlitic malleable cast iron. So it is designated like this: WM 350, WM 400, BM 300, and so on. Again this indicates the tensile strength. So you can understand from this WM, that is white heart malleable cast iron, having ultimate tensile strength of 350 Newton per mm square.